This clip demonstrates the aggregation framework in MongoDB. So we're using the movieDetails collection, and the previous clip ended with an example of an aggregation framework with two stages in it. So it was how many movies are on record for each of the rated values, the rated categories. So when we executed this clip, the results were as follows. So we saw that for each of the rated categories, one document appears. So for the category R, there's a total of 214, PG, it's 153, and so on. PG 13, sorry, it's 153. So this aggregation pipeline had two stages in it. So all the documents in the movie's collection were within scope. There was no elimination of documents from the grouping. So all documents got into the group stage, and then the grouping was applied, and then the documents were passed on, the resulting documents were passed on to the sort stage. So hence we saw the output with the largest values first. So the 1599 followed by 214, 153, and so on. And then because there are a lot of documents in the output, there's a cursor there, and if we iterate the cursor by typing IT, we'll see the remaining documents that emerge. So from an SQL perspective, that's the equivalent of a group by query, where we're grouping by the rated column if we were dealing with a table, and we're ordering by the rated column as well. So now we're going to take it a step further. And this time we don't want all the documents to be considered. So the question this time says, how many movies are on record around the system for each of the following rated values: G, PG, PG-13, and R. So now what we're doing is we don't want all of the documents to get to the group stage. We want to filter out some of them. So the way you can filter out some of the documents and prevent them from getting to the group stage is having a match stage before the group stage. So here we have a match stage. The match stage says match those documents that have a rated value that's one of the following. Whether it's G, PG, PG-13, or R. So only documents that meet any one of those four values will be passed to the group stage. And then the group stage will do its work and pass its results onto the sort stage. So here we have an aggregation pipeline that has three stages in it: a match stage to filter out documents, a group stage to do the aggregation, and then a sort stage to sort out the results and present them in whatever way we see fit. So we'll just execute the query or the aggregation, and again we'll clear the screen. And what you notice this time is there's much fewer documents generated in the results. So what's happened is that only documents that met the four rated values got passed to the group stage, and hence we only have four documents in the results. And again, they're sorted in reverse order by the number of movies for the particular category. So that's why you see R is first with 214, PG is second in the list with 153, PG-13 is second, PG is third with 108, and G is last with 31. So the equivalent SQL command might be something like select rated, count star from movieDetails where rated N, G, PG, PG-13 are group by rated, order by rated in descending order. So what's happening here is that, as the where clause in the SQL version of the command might suggest, is the entire set of documents in the movieDetails collection aren't considered at the group stage. Only those which are that pass through the match stage or filter to the match stage get to the group stage. The other thing that's important to remember here is that the rated $rated in the group stage, we reference the rated column as $rated, whereas in the match stage we just reference it as rated. So the rated in the match stage we don't include $signs as we mentioned field names, whereas in the other stages we do. So that's an important distinction to bear in mind. So the query, as I said, eliminates documents that don't meet the four values for rated. Only those documents are considered, and therefore we only have a maximum of four documents in the results. Now, what we can do then is we can take that and narrow it down further. So as you can see there, that there's 4 documents in the results, 214 for R, PG13 has 153, PG has 108, and G has 31. So we can now take our aggregation framework a step further, and we could eliminate, we'll say, results that aren't 40 or above. So 3 of our 4 documents here in the results are 40 or more, whereas the 4th one, the bottom of the list here, is 31. So if we want to achieve that in the aggregation framework, what we do is we introduce another match stage. So the question here in number 5 says, how many movies are on record for each of the following rated values? The 4 rated values we've mentioned already. But the key additional part of the question is, we're only interested in cases where the totals generated are 40 or more. So therefore, the one you can see over here on the right-hand side in the Mongo screen, the 31 should be eliminated. And the way you eliminate that one from the results is you introduce a match stage below the group stage. Okay, it has to be before the sort stage, but it has to be after the group stage. So we have another match stage introduced here. So the initial match, as I said, decides what documents get considered. The grouping or aggregation then takes place. Then we have the results of the grouping are passed on to the next match stage. And at that point, we filter out those where, we only include those where the number of movies per rated category is greater than or equal to 40. And then we finally sort them. So when we execute that pipeline, what you'll see is that when I leave the 2 of them actually on screen, I won't bring across the clear screen message. Execute this one. You now see there's 1 fewer row. There's 3 documents in the results in this stage. In this example, so the 31 for G has vanished, and the other 3 have remained. So that's how you take it, and you can prevent some of the results from the group stage being included in the output. So from an SQL perspective, this is the equivalent of introducing a having clause in our query. So our query now might read in SQL, select rated, count star, and I put an alias in it, I put a column alias there, number of movies per rated cat. Because that alias is going to be used in my order by later on. So it's from movie details. The where clause determines what documents get filtered or pass the test for consideration. We then group by the rated column, and we say having count greater than or equal to 40. We're only interested in cases where the count is above 40. And then we're sorting by the number of movies in the per rated category. So we're sorting by that field in descending order. So that's the SQL version of the query. So as I said, at this stage, we now have an aggregation pipeline that has 4 stages in it. The match stage is in many cases, in many aggregations, match stage is always the first stage. But then we have a group stage, and then to prevent some of the results of the grouping stage being displayed on screen, we have another match stage, and that other match stage eliminates those that aren't 40 or more, and finally we sort them in a sort stage. So that's an example of an aggregation framework that has a total of 4 stages. And that's the end of the clip.